Hello, we're going to be working on lesson 33-1, fitting data with a quadratic function. This is from Springboard Algebra 1. So the first thing we want to do before we get started is to mark our learning targets. So the first learning target is to write a quadratic function and use a quadratic model. All right, we're talking about a model rocket. So I'm just going to kind of skim over the information that's given to us in these paragraphs. Cooper has a model rocket, and he has certain ones that can rise up to 1,000 feet, depending on the engine size. After the engine is ignited, it can burn for 3 to 5 seconds, and then it accelerates upward. It has a parachute that will open as the rocket begins to fall. So Cooper wanted to investigate the flight of this rocket from the time the engine burns out until it lands. He set a device in the rocket named Spirit, and that begins to collect the data from the moment the engine shuts off. Unfortunately, the parachute failed to open, so when the rocket began to descend, it was in free fall. All right, so look at our table. It gives you the time since the engine burned out and the height. And time is in seconds, height is in feet. So question number 1A asks you to use the table to determine whether the height of Spirit can be modeled by a linear function. So what do you know about a linear function? Remember, linear means it has to have a constant rate of change. So as we look at our time column, each of those are increasing by 1. So from 0 to 1, 1 to 2, 2 to 3, 3 to 4, and so on. So these all have an increase of 1. But what about our feet column, the height? So the height is not increasing by 1 or even as a constant rate of change. So from 512 to 560 is an increase of 48. 560 to 576 is an increase of 16. 576 to 560, now we're decreasing by 16. So there is a pattern, but it's not constant. So number 1, is there a constant rate of change? No. So it cannot be linear. So question B asks you to just plot those points. So I've already done that for you. So at time 0, you're at 512 feet. At 1 second, you're at 560. 2 seconds is 576. 3 is 560, and so on. All right, question number 2. How high was the Spirit when the engine burned out? So when the engine burned out is when it started. So at time 0 is when our engine burns out. So that would be at 512 feet. How long did it take the rocket to reach its maximum height? So where is the maximum height? So our maximum height is right here at 576 feet. So how long did it take? 2 seconds. Estimate the time that the rocket was in free fall before it reached Earth. So free fall, Earth is at height 0, right? So it's reaching at about 8 seconds. So I put 7 to 8 seconds because you're estimating. Even if you freehanded this graph, you're not always going to end up exactly at 8 seconds. All right, so use the graphing calculator to determine a quadratic function for the data. So if you remember, to find the quadratic function, we need our quadratic regression. So the first thing we're going to do is just type in our points from our table. So we go to Stat. I'm going to leave it on Edit. So I've already got my points typed in here. So L1, and you need to make sure they say L1 and L2. L1 is just your times, so from 0 to 6. And L2 was the height, so 512, 560, etc. So now that I've got my times in there, my times and my height, I need to calculate the regression. So Stat, I'm going to go over to Calc. And I want number 5. We want a quadratic regression. Okay, so it gives us the formula, negative 16x squared plus 64x plus 512. Okay, sketch the graph. We've already done that. And then give a reasonable domain and range. So domain, remember, domain is your x values, which is always your independent time. So in this case, that's our time. So in this situation, our time is from 0 to 8, and it includes the 8. Okay, what's the range? The range would be your y values. In this case, that's our height. And our height is from 0. What's the tallest? 576. So the domain is from 0 to 8, and the range is from 0 to 576. Use the function found in item 3 to verify the height when the engine burned out. So the engine burned out at time 0. So you just plug 0 in for time. So negative 16 times 0 squared plus 64 times 0 plus 512. So your zeros just go away and you end up with 512 feet. Okay, can you determine the interval in which the spirit was in free fall? So it's in free fall when? For a total of 6 seconds. So it started at 2 seconds and it landed at 8 seconds. So that gives you your total free fall. All right, so 33-2, interpreting solutions. So the first thing it asks you to do is just to rewrite the equation, and then B is to completely factor that. So if we're going to completely factor this, we have negative 16 t squared plus 64t plus 512. Oops. All right, so the first thing we want to do is find a common factor. So what can I factor from 16, 64, and 512? I can factor out a negative 16. So this is just a GCF. So I'm going to factor that negative because I'd rather my first term always have a positive value. So I have t squared minus 4t minus 16 goes into 512 32 times. All right, so this negative 16 you just kind of bring down. So when you're factoring here, I'm looking for factors of 32 that will subtract to give me 4. So that would be t minus 8 and t plus 4. So 4 times 8 is negative 32. Negative 8 plus 4 is the negative 4, and then t times t is t squared. So that's just kind of a quick run through way to check. But I obviously would have my t's, my linear term, with this middle. So that would be your positive 4t and the negative 8t. Okay, on C, it asks you to identify and use the appropriate property to find the time that it took the spirit to strike Earth after the engine burned out. So that would be the zero product property. So that is when we take our factors and just set them equal to 0. So if I set this equal to 0, I would add 8 to both sides, which means t equals 8. If I do t plus 4, I would subtract 4. So that would be t equals negative 4. So can time be negative? No. So t equals 8 is your time that it took to hit Earth. All right. Draw a horizontal line on the graph in item 1 in lesson 33-1 to determine the height above at 544 feet. Okay, so I'm going back to look at that graph. It's already got this line drawn here for 544 feet. So I'm just going to copy this real quick. So we have it over here with us. Okay, number 3, the time that the spirit was 544 feet above Earth can be determined exactly by finding the values that make h of t equal 544. So we're going to rewrite that equation and set it equal to 544. So the same equation. So we have negative 16t squared plus 64t plus 512 equals 544. Okay, is the method of factoring effective for solving this equation? Well, can we factor it? What do you have to do before you can factor it? First, I've got to get it equal to 0. So I need to subtract the 544. So we have negative 16t squared plus 64t minus 32. All right, so can we factor this? So first we're going to factor out that negative 16. All right, so can I find factors of 8 that add to give me 4? No. So can I factor this? Is the quadratic function or quadratic formula effective for solving this problem? So quadratic formula, all right, so I'm using this function here. So A is 1, B is negative 4, and C is 8. So if you solve this, you end up with 2 plus or minus the square root of 2, which gives you approximately 0.586 seconds and 3.414 seconds. So if we look at our graph, are those reasonable answers? All right. So why is it more appropriate to round to the thousandths place than to use the approximation or the exact answer? So if we round it, we can at least see on our graph what it means. If I'm using this exact answer, what does 2 plus the square root of 2 mean? Or 2 minus the square root of 2? I can't visualize that. Okay, so number 4 is asking you to do the same thing, except you set it equal to 528. So subtract the 528. So we can factor a GCF. Doesn't factor, so we need to do the quadratic formula again. When you do the quadratic formula, you end up with 2 plus or minus the square root of 3. So when you add the square root of 3, you get 3.732 seconds. And when you subtract it, you get 0.268 seconds. Okay, so write an inequality to represent the values for t for which the rocket was not within Cooper's sight. So when it was between 0.2685 seconds and 3.732 seconds, it was not in his sight. All right, number 5 asks you to determine the time when the rocket was on the ground. So that's when you set it equal to 0. So we have negative 16t squared plus 45t plus 220. So I can't factor here because I don't have a number that goes into 16 and 45. So you have to do the quadratic equation again. So that's negative b plus or minus the square root of b squared minus 4ac all over 2a. So remember, this is a, this is b, and this is c. So when you plug those in, you end up with 5.372 seconds. Okay, when is it greater than 220 feet? So I'm going to set it equal to 220. When I subtract the 220, I would get negative 16. Uh-oh. So when I subtract the 220, that just goes to 0. So all I can factor here is a t. So time equals 0. And then time is, let's see, that would be negative 45 over 16, which is negative 2.8125. So the height is greater is from 0 All right, that should do it for you. Thanks for listening.